Hey friends, this is Bidhan. Welcome you to my channel. Today we will see a problem from June 2012 part B from operational amplifier. In the open circuit shown in the figure below, the input voltage Vi is 1 volt. The value of the output voltage V0 is input voltage is 1 volt and this input voltage is going to negative input terminal and positive terminal is grounded. That means it is inverting operational amplifier. Now this is inverter with open loop or with feedback circuit. Obviously this is inverter with feedback circuit because we can see there is a feedback circuit going from output to input. So this is a circuit that is an inverter circuit with feedback. We have to find the output. Now I have drawn this circuit on my board, this one, and I have also drawn a standard inverter circuit with feedback, and I have written down the output of standard feedback circuit, that is minus RF by R1 into Vin input. This is RF and this is R1. Now compare this. Now compare our given circuit with the standard inverter circuit with feedback. You see here the output at this point is this one, and this output, this voltage is same as the voltage at this point. That means this point is also V0, V output, and this point is also the same point, V0. That means the output formula that you were looking at, this is valid at this point and also at this point. All are the same voltage points. But here you see that this is the output that we have to find, and this output voltage point is same as this point. They are same voltage points, but this voltage point is not same to this voltage point. This is a different voltage point. That means just after the operational amplifier, the output that we have is the ideal output, for ideal inverter circuit with feedback. Here also, just after the operational amplifier, the output we will get is the ideal output for the operational amplifier. So if I write down this IO to name it ideal output, IO, that means this voltage is actually at this point, VIO, and this is the output that we have to find. Since I have to name it differently, that's why I have put it here IO, so ideal output, and this is it, this is the ideal output. So at this point the output is minus RF by R1 into V input. So let us find out what is the output at this point, and at this point the output is minus 1k, this is RF and this is R1, 1k by 1k into voltage is 1 volt, it is minus 1 volt. That means at this point we have minus 1 volt at this point, and this is the ideal output. Now this ideal output is exposed to a voltage divider circuit. Here you can see, that means this voltage of 1 volt minus 1 volt, the magnitude is 1 volt, but minus just shows the polarity that it's a negative voltage, because there is no negative voltage. Voltage is always positive, but it shows the polarity. So minus 1 volt finally will drop to 0 at this point. That means in this circuit the voltage that we provide here, or that we get here as the output, as the ideal output, that will finally be dropped completely in this voltage divider circuit. So there will be a drop across this and there will be a drop across this. And the voltage at this point, what is the voltage at this point that we have to find? Because we have to find V naught, and this V naught is voltage at this point, and the voltage at this point is actually this voltage, the ideal voltage, minus the voltage drop across this resistor. So for that we have to find out the voltage drop across this resistor, and the voltage drop across this resistor is voltage drop across 1K when -1 is the EMF. It is -1 EMF times this resistance, that means 1 10 to the power 3 1K by all the resistances added, equivalent 10 to the power 3 plus 10 to the power 3. It is -1 into 10 to the power 3 by 10 to the power 3, let us take common, 1 plus 1, minus 1 into 1 by 2, that means minus 0.5. So minus 0.5 volt drops across this resistor. So what is the voltage at this point? At this point we have, initially it was -1, now minus 0.5 dropped, so it is -1 minus of minus 0.5, that means -1 plus 0.5, so minus 0.5 voltage is present at this point, and this minus 0.5 volt will finally drop to become 0 here, but it doesn't matter, we have to find the voltage at this point, and this goes to here, so it is the output. So the output is minus 0.5 volt. So here again we have application of voltage divider circuit. So here we get the standard output as per the standard law. This output we know for the standard circuit we get here, and now this output drops here by minus 0.5 volt. So here we have this voltage, the ideal voltage, minus this drop. So at this point we have minus 0.5 volt. So the answer is B, minus 0.5. But again let me tell you that for this specific problem also there is a confusion, that somewhere I have seen the answer is C, but somewhere I have seen the answer is B. But now it is clear, and this is the right answer, minus 0.5. So answer is B. Thank you.